Okay, in this video, we're going to go through and try to get at the idea of the difference between different kinds of batteries and cells. So first of all, a cell is comprised of two electrodes and an electrolyte connected together. So we've looked at the cathode and the anode, and you've got an electrolyte. The electrolyte has the ions that are moving, and this allows the reactions to occur and be separated, and the electrons to travel through the external circuit. That's when a cell is useful to us. But batteries are a little bit different. Batteries contain two or more cells linked together to give a combined higher voltage. So if you think of the back of your TI-83 or whatever, your calculator, it's got several batteries that go into the back. I think it's four triple A cells. So the cells are the triple A's that you put in. And when you put all four of them together, they're in series, and that makes them into a battery. There are three different kinds of cells that are present. We've got primary cells, secondary cells, and fuel cells. Primary cells here are single-use cells. So these are going to be single-use, and they're going to be the kinds of cells that you'll go and recycle them as soon as you've used them. They're not possible to recharge. And so the primary cells have several different kind of arrangements, but usually they are the ones that we're used to seeing. They have a paste, they have an electrolytic paste, and they're going to have a two electrodes. And so in this Leclanche cell, and nobody's going to ask you for the name of this cell. It's not really that important. It's got a carbon rod and a zinc case. Those are the two electrodes, and it's got manganese 4 oxide as well as a moist paste of ammonium chloride. So the ammonium chloride is going to be the electrolyte, and then you've got the two electrodes here. The zinc is your strongest reducing agent, and so we've got the Leo Ra anode. So at the anode, you've got this zinc. At the cathode, you're going to have the gain of electrons reduction. The oxidizing agent happens at the cathode. And here, you can see that ammonium paste and the manganese 4 oxide are going to react. And so if we can keep track of the entities, we can figure out what the spontaneous reaction is, what the products are, what things are going to be used up. So the reactants are used up, and the products are being made. So we're going to get an increase in zinc ions in these. And those are the sorts of questions that you might be asked. Where is the anode? Where is the cathode? And it's all based on what the spontaneous reaction is. And this next cell looks a lot like, very similar to it. This is kind of like our copper top. This is the regular cell you might see fairly frequently. In this case, it's got zinc. It's got zinc 4 oxide. And again, you're going to get a similar kind of a reaction occurring, but it's slightly different. It's going to, again, have an electrode. It's probably going to have a carbon electrode. It's going to have a paste. In this case, the paste is going to include some hydroxide ions. And you're going to get these reactions occur. It's spontaneous, and the voltage is a result of the two reactants, the cathode and the anode. A mercury cell is just another kind of design, and in this case, it's got a zinc container, and it's got a paste of mercury 2 oxide, and the mercury 2 oxide with water react, and the zinc and hydroxide react to produce this voltage that's here. All of these primary cells are going to be one use, single use, then throw away, well, hopefully recycle, and they'll recover those chemicals and try to make them useful again and not go into the landfill. Secondary cells are probably a little bit more common, but often kind of invisible to us because these are the cells that are rechargeable. And so our rechargeable batteries, every time you're plugging in a device and it's getting a charge, that means it's a secondary cell. And it's going to have two kind of modes. It's going to have the mode where it's a voltaic cell, and it's going to have a mode where it's an electrolytic cell. So we're going to have the strongest oxidizing agent above the strongest reducing agent. That's when it's acting as a voltaic cell. But then they need to take the chemicals here and recharge them to make them back. We need to do the recharge. So the recharge is going to produce that and produce that. And this part of the reaction, when you've got those two chemicals being recharged, is when it's an electrolytic cell. Electrolytic cells use electricity um, to force a reaction that wouldn't spontaneously occur. We're going to study those in the next one, but basically the secondary cells are going to have both a strongest oxidizing agent spontaneously reacting with the strongest reducing agent, and then they're going to have the strongest oxidizing agent is going to react with the strongest reducing agent. This is when it's voltaic, and this is when it's electrolytic. And so this is when it's being used to give energy, and this is what's happening when it is being recharged and plugged back into the wall. So lithium batteries are super common. They're in all sorts of things. The anode is a lithium, and the cathode is titanium 4 sulfide. They're very light, so they're useful, and they give off a lot of electricity. So they're quite useful. They can get hot, so they do have some limitations. We don't want to get too many of them together. Um, but it gives off a lot of voltage, so we don't need too many lithium batteries to be able to get quite a bit of product. And because they're light, they're quite useful. Nickel cadmium cells, these are older style rechargeables, and they're kind of heavy. They look a lot like your standard cells, but you can put them into a recharger. And so when this and this react, that's a spontaneous forward reaction. But when it's recharging, what we're going to have is this and this will react, and that requires electricity. And so it's rechargeable, but when it's recharging, what's happening is the reaction is going to be reversed. It's going to go the other way. Um, Lead storage batteries are really common, and these are common because they're used in vehicles. So lead storage batteries give off a lot of voltage. They're extremely reusable, and they're very common. So they can stack up a lot of the cells together to get a lot of voltage, enough voltage to get your car going. But they're also fairly easy to recharge using the engine's energy while it's running. And so it's got an alternator that recharges the battery in your car. So the forward reaction has lead and sulfate ions with lead 4 and acids. And that's our spontaneous reaction. And we produce lead 2 sulfate and water. But we can reverse the lead 2 sulfate and water reaction to recharge it. The lead storage batteries are extremely toxic, so we never want those to go into the landfill, but they are very easy to recover the chemicals. And so if you take them into the recycling centers that we've got in the city, they're able to get all of the chemicals back out of them and reuse them. And so they're actually fairly clean as long as they don't get a leak in them. Fuel cells are different. So fuel cells are not rechargeable. They're still kind of they're only going to do the voltaic reaction. But what happens is the fuel cell is going to use a chemical as fuel. So in your car, you'd be putting in gasoline, and the gasoline gets converted to heat and kinetic energy that moves the engine parts around. Instead, what we get in a fuel cell is they're going to put in a different chemical, and it's going to react and give off electrical voltage. So if they have a tank of hydrogen gas and we use oxygen from the atmosphere, this will produce water and it gives off electricity. And so it's fuel because we have to keep replacing the hydrogen, but it can keep running. So they use hydrogen fuel cells for things like buses and things that are going to be used for commuter engines where they can just refill the hydrogen. It doesn't need a recharge. They just need to replace the hydrogen tank and the vehicle continue running. It also is quite nice because water is, it's naturally occurring, but it is also plentiful. And while it is a greenhouse gas, it usually condenses in the air, and so it's mostly going to be just water vapor. So it's a lot less sort of environmentally challenging. Um, an aluminum air cell, in this case, they would use aluminum is the fuel. So they're going to have to replace some aluminum rods in this, and then the air is going to be reacting. So you get water and oxygen react with aluminum and oxygen. It's going to produce this aluminum hydroxide paste. You're going to have to remove that, and you're going to have to replace the aluminum. But we've got lots of oxygen around, and so we can have that reaction occur, and it can be an ongoing source of electricity. So from these, I want you to know the difference between primary cell, secondary cell, and fuel cells. If you're given a diagram, figure out what the reactants are and what the spontaneous reaction is, maybe be able to interpret what the voltage would be from that cell, and then be able to um, identify the parts. So what's the anode, what's the cathode, which direction are the electrons flowing, those sorts of things.